Okay, so we're going to talk about functions defined by tables and graphs. And we are going to understand what a function is, and we're going to define a function by using tables, graphs, and equations. So a function is a correspondence between two sets of data, the domain and the range, that assigns each member of the domain exactly one member of the range. Each member of the range must be assigned to at least one member of the domain. So you can represent a function either as a correspondence, as stated in the definition, or as a set of ordered pairs, as shown in example 1. So we tend to do things in ordered pairs. It just makes more sense for algebra. So if we look at example 1, the birthday function matches each person with his or her birthday. So some of these pairings would be below. So George Washington, his birthday is February 22nd. Marie Curie, hers is November 7th. Charles Darwin has a birthday of February 12th, as does Abraham Lincoln, has a birthday of February 12th. Now we know these are functions because for George Washington, there's only one birthday. For Abraham Lincoln, there's only one birthday. And even though Charles and Abraham share the same birthday, nobody really cares because there's a specific one assigned to Abraham and there's a specific one assigned to Charles. So that makes them a function. Okay. And we can write each pairing as an ordered pair. So here we have George Washington, February 22nd, Marie Curie, November 17th, Charles Darwin, February 12th, Abraham Lincoln, February 12th. And this might look kind of weird to you, but this is something that is used in computer programming. So in computer program, we don't always use numbers. We can use data that's written as words. Okay, so this is something you might actually see if you're doing some sort of coding. Okay, so the table at the right shows the average height in feet associated with each of several types of trees. So these are, we have the Douglas fir, which is like a pine tree, juniper, oak, poplar, and yew. And these are their average height when they're fully grown. Okay, the table provides a rule by assigning one height to each tree. The domain of the function is the set of first coordinates. So the domain is always like your x value. Douglas fir, Jupiter, oak, poplar, yew. Okay, so there's my domain. The range is the coordinates of the second set. So here's my range, 10, 12, 25, 30, 43. It is easier to compare the heights in a bar graph. So this type of data is going to be easier to use a bar graph to show. So here we have, dun, 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 there's our bar graph where we have the different types of trees and their heights. Okay, so it says draw a bar graph for the function in the table of example 1. We did that. So basically what I did was I chose an axis for the domain. So here's my domain, okay, and it's usually the domain is on the x-axis, not always. And then I use the range as my y-axis, okay, because this depends on what that is. I listed the members of the range on the left in numerical order. I did the ones at the bottom, the domain at the bottom. I started my scale at 0, okay, so that relative to each other it would make sense. If I started it at 5, then we'd say, wow, these are really short trees. Okay, so you can see they're not quite as short as they thought. Okay, so you guys know how to make bar graphs. Okay, when a measurement varies over time, we say that it is a function of time. For functions of this type, it is better to use a broken line graph. Now you're used to them being called just line graphs, but it's a broken line graph because the line breaks, okay? And basically what that means is, if we look at this graph here, this was the population in 1900, this was the population in 1920, but these are not necessarily the populations for the years in between. It might kind of go like this, it might kind of go like that, okay? So we say it's broken line because the only data we have are the actual points. So the information in between isn't really showing you the data, it's just basically showing you the trend. Okay, so that's why it's called a broken line graph. Okay, so it says draw a broken line graph for the function in the table below. We always do time along the, I can't show you everything, wow. We always do time along the x-axis, okay? So anytime there's time, line graph shows change over time, the time goes on the x-axis, okay? We had our population here. It's in millions, okay? So rather than doing, millions, I just use how many millions it is. Okay, so there's that there. We listed the members of the domain along the horizontal axis. For each member of the domain, we plotted a point to represent the corresponding value in the range. and then we connected the points by line segments, okay? But the main thing to remember about a broken line graph is the dots are your actual data. The lines in between don't represent data, they represent a trend, okay? Next page. Note that the line segments in the graph in example 3 do not necessarily show the actual population. I just explained this. However, they do help you estimate the population and to see the trend over time, okay? So I can use these to estimate. I could say, well, in 1910, it was probably about whatever this point is, whereas these are accurate. This is an estimate. Okay. So let's look at the try this. State the domain and range of the function shown by the table. So this is the cost of seeing a movie at the Bayou Theater. Okay, so the domain for this is going to be the year. So my domain is going to look like this. I'll have 1940, 1950, 1960, 1970, 1980, and 1990. Okay, so there's my domain. Okay, the range then is going to be the cost. So I'm going to have 30 cents, 60 cents, $1.25, $2, $3.25, and $5. Okay, notice that I didn't abbreviate. Okay, I wrote it the way it is. I kept these in dollars, I kept these in years. Okay, that's the way you have to do it. So then the ordered pairs are going to look like this. I'll have 1940 with 30 cents, and I'll have 1950 with 60 cents, and 1960 with $1.25, and 1970 with $2, and 1980 with $3.25, and 1990 with $5. Okay, so those are my ordered pairs. Okay, now we're going to graph it. Okay, and we're going to do a broken line graph. So these are the ordered pairs that I'm going to graph. So here on the bottom, I'm going to put my years. So let's call this, we'll make this 0. And my years, I've got 1, 2, 3, 4, 5, 6 years. So let's divide this like this. Lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I can do like 5. I'll start here. 2, 3, 4, 5. Let's do 3. 3 here. So here is 1940, and then I'll count over 5. 1, 2, 3, 4, 5. 1950. 1, 2, 3, 4, 5. I don't think that's going to work. 60, 70, 80. No, it does work. Look at me. Look at me. 1960, 1970, 1980, and 1990. Okay. And then for my dollar amount, since this is in cents, I'm going to spread it out more. So if this whole thing is $5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We'll go down here. So that's 20. So each one is 4. 1, 2, 3, 4. There's $1. 1, 2, 3, 4. There's 2. 1, 2, 3, 4. 3. 1, 2, 3, 4. 4 and 5. Okay. Putting the graph together is the hardest part. All right, so then I'm going to graph them. So 1940, it was 30 cents, which would be probably like right around here. And in 1950, it was 60 cents, which there's 50 is going to be right around there. 1960 was $1.25. So there's $1. No, there's $1. $1.25. 1970 is $2. So here's $2. 1970. 1980 was $3.25. So here is 3. Here's $3.25. And then 1990 was $5. There it is. So then I'm just going to connect the dots. I'm going to do straight lines. I'm not trying to make it look like a curved line. Actually, lines aren't curved. So I remember that the in between parts, that's not real data. You can use it to estimate. Okay, but it's not actual data. It's really just showing you the trend. Okay, so there's my broken line graph. So if I wanted to know what was the cost at the Bayou, or however you say it, Bijou Theater in 1965, I could estimate that it was probably like $1.60. Okay, estimating that. All right, and that is it. Okay, so you just got to be able to take your table, know what the domain is, know what the range is, make your ordered pairs, and graph it either as a line graph or as a bar graph.